Hello once again. Welcome to our YouTube channel. Today we'll be covering the development of the glands of the neck region. Remember, we'll be covering development of the structures of the head and neck. And the last video that we did was actually on the development of the tongue. We also had other videos on the development of the jaws, development of the teeth, development of the face, development of the lacrimal apparatus. So kindly feel free to go and watch those videos, including also development of the eyes and the development of the ears. So we've covered that extensively. So today we'll be covering now the development of glands of head and neck. And of course, by the virtue of this anatomy made easy. So we'll start by looking at the anatomy of the thyroid gland and the parathyroid gland. But I'd like us to appreciate that the thyroid gland is just anterior to the trachea and is found on the neck region. It has two lobes and an isthmus connecting them. Sometimes it has a pyramidal lobe. You can see it there. We talk about the origin of the pyramidal lobe. Then you can appreciate posterior to it, you have two pairs of parathyroid glands, that is superior parathyroid glands and two inferior parathyroid glands. So that's the normal anatomy of the thyroid glands. Now, regarding now the embryological aspect of the thyroid gland, the tissue of origin of the thyroid gland is endoderm. So that one should be noted well. The tissue of origin of the thyroid gland is the endoderm. That is now the parenchymal aspect. Then the epithelium. So what happens is that the epithelium of the endoderm on the floor of the pharynx, that is the floor of the pharynx, that is stomodium, it will proliferate. So the epithelium on the floor of the stomodium, floor of the pharynx, will proliferate, and with the proliferation, it develops downwards to form a diverticulum. So it proliferates, forms a diverticulum, and that diverticulum develops downwards between this developing tuberculum impar and the copula. Remember the tuberculum impar was forming the anterior two-thirds of the tongue. The copula was forming the posterior one-third of the tongue. So tuberculum impar, anterior two-thirds of the tongue, copula posterior, one-third of the tongue. So this diverticulum now will develop in between on the boundary. And that's how a foramen cecum is formed. So foramen cecum forms a very important landmark and actually a stage in the development of the thyroid gland. So we've had the endoderm proliferating downwards to form the diverticulum. The diverticulum forms the foramen cecum. Then this diverticulum also continues to descend downwards as a bilobed diverticulum. So it was just a single diverticulum, then it descends downwards. But now, it having been bilobed, then it remains attached to the tongue. Remember, the foramen cecum is formed on the future on the future stomodia or the future mouth. So it is forming on the level of the tongue. So this developing thyroid gland, which is descending downwards, remains attached to the tongue where the thyroglossal duct is. So it descends downwards at the level of the hyoid bone, and then after some time goes downwards at the level of laryngeal cartilages. So at different stages at different times. So it continues to descend downwards, the level of hyoid bone, and then at some time the level of laryngeal cartilages. Then at the final position is reached at the 7th week in front of the trachea. Now the final position is now the 7th week in the front of the trachea. And then this developing thyroid gland will be invaded by the cells of the ultimobrachial body to form the parafollicular cells. So that's the parenchyma aspect. That's the parenchyma aspect of the thyroid gland. So what about now the stromal stromal aspect. The stromal aspect will come from the surrounding mesenchyme cells. So you differentiate to form the capsule and the trabecula, the septa that will divide this gland into various lobes and lobules. So parenchyma comes from the endoderm, and then the stromal aspect will come from the surrounding mesenchyma descending downwards. What about the cell types? So of course, you know the thyroid gland has the follicular cells. These are the follicular cells and the parafollicular cells. That also it has C cells. So the follicular cells, which ideally forms the colloid, which this colloid contains thyroglobulin, which gives us the thyroxine and thyrothyrone, will also be coming from this parenchyma, the endoderm. But the parafollicular cells, which comes from the ultimobranchial body, which forms the calcitonin, at this point will be coming from the ultimobranchial body. Remember, the ultimobranchial body comes from the pharyngeal arches. So the cell types, follicular cells, which form the thyroglobulin, which is stored in the colloid, gives us T3 and T4, thyroxine and triiodothyronine. Then parafollicular cells, which forms the calcitonin hormone, comes from the ultimobranchial body, from the neuronuclear cells, where the pharyngeal arches. So that's the development of the thyroid gland. What about the anomalies? So for the anomalies, we'll have now the thyroglossal system fistula. We'll see that in a few minutes. Then you have aberrant thyroid tissue. Then we'll have this aberrant thyroid tissue happens to be most of the time in the tongue. So that ectopic thyroid tissue will be present in the tongue most of the time. So you can appreciate this is a part of flow of how it descends. So it develops from the foramen cecum, then it goes downwards, leaving behind this thyroglossal duct. Then the normal level now is attained at around the 7th week in front of the trachea. So it goes on the sublingual level, the suprahyoid level, the hyoid level, the tracheal, the laryngeal level, and then on the tracheal level. So actually those levels, you can have ectopic glands being left there. What are some of the anomalies then? You can have ectopic lingual thyroid glands. You can have intralingual thyroid glands. You can have thyroglossal cyst, thyroglossal duct cyst. Then you can have now a low neck ectopia. These are low neck ectopia. Then you can have now the normal location of the thyroid gland. You can have intratracheal position of the thyroid gland. And then also you can have this thyroid gland descending downwards more than it was supposed to be. So when you're having the mediastinal thyroid gland. Some of the anomalies of your thyroid gland in terms of being ectopic. So lingual thyroid gland, intralingual. You can have a fistula or a cyst of the thyroglossal duct. Then a low neck ectopia. You can have a normal now thyroid gland as a normal position of it, just in front of the trachea. Then you can have intratracheal position. Then you can have it migrating downwards more, it descends more, and find itself in the mediastinal position. Now, in terms of the parathyroid glands, of course, you know they are found posterior too. Posterior on the surface of the thyroid gland. So how do they develop? So those are the two parathyroid glands we're talking about. Of course, you know this is the thyroid gland. Maybe it's something that we didn't mention in the development of the thyroid gland is that you can have a portion of this thyroglossal duct forming the pyramidal lobe. Remember, the pyramidal lobe is formed on the just inferior aspect of the thyroglossal duct, which now doesn't obliterate and then forms that duct, that pyramidal lobe. A point to appreciate is that this thyroglossal duct is supposed to obliterate. If it doesn't obliterate, Now it will form fistulas and cysts. The thyroglossal duct is supposed to obliterate, but just maintains its connection with the tongue. So how then does the parathyroid glands develop? So they develop from endodermal proliferation of the third and fourth pharyngeal pouches. Of course, we know a pharyngeal arc at this point, it contains a cleft, a pouch, and a tissue, which now will give you the muscles, the arteries, and other structures. So the parathyroid glands at this point, they develop from endodermal proliferation. So tissue of origin, endoderm. What does it do? Proliferates. Then both the third and fourth pouch will divide into a ventral aspect and a dorsal aspect. So both the third and the fourth pharyngeal pouches will divide into a ventral aspect and a dorsal aspect. So for the third pouch, the ventral part will form the thymus, and then which descends inferiorly, and then the dorsal aspect will form the inferior parathyroid. So when now the thymus is descending inferiorly with the mediastinum, it will migrate together with the inferior parathyroid gland. And that's the reason why the inferior parathyroid gland is found below superior parathyroid gland, despite it coming from the third pouch. So the ventral aspect of the third pouch gives us the thymus, and then the dorsal aspect gives us the parathyroid gland, and then the thymus migrates downwards towards the mediastinum. So now the inferior parathyroid gland migrates inferiorly as the thymus migrates, and the normal position now is arrived at around the 7th week of development. What about the fourth pouch? The fourth pouch, the ventral aspect will give us the ultimobrachial body, which gives us the parafollicular size of the thyroid, as you noted earlier. So the ventral aspect of the fourth pouch, the ultimobrachial body, which gives us the parafollicular size of the thyroid. What about now the dorsal aspect? The dorsal aspect now will give us the superior parathyroid gland, which reaches its normal position around the 5th week of development. So actually, parathyroid glands, we just develop very simple. Like the ventral aspect of that pouch as it is migrating downwards, migrates together with the inferior parathyroid. Then the fourth pouch, I have the ultimobrachial body giving us the parafollicular cells of the thyroid, but now the dorsal aspect of the fourth pouch gives us a superior parathyroid, which now has its normal position at around the 5th week of development. So this is just to show us the migration downwards. At this point, we have now this is a third pouch. This is a fourth pouch. So the third pouch will give us, it divides, we have now the ventral aspect. This is the ventral aspect, the thymus, and then this is a dorsal aspect. So as it's migrating downwards, it migrates together with the parathyroid gland, the inferior parathyroid gland. Then you can appreciate this is now the fourth pouch. This is a parathyroid gland, the superior parathyroid gland, then this is a ultimobrachial body. So this one would migrate that much, but it will also migrate downwards. But you can appreciate the one will migrate more is the inferior parathyroid gland coming from the endoderm. Remember, at this point, this tissue is lined by endoderm. And then this is a developing pharynx. You can also try to appreciate that this thyroid gland is also developing, and this aspect is descending downwards while maintaining its connection from the tongue. Paramexicum drew by the thyroglossal duct, as you can see here. So it's a median thyroid gland with a true bilobed diamanticulum, as you can see here, which is migrating downwards. So these are now the 4th to 7th week of development happening here. So you can appreciate now this now in the summary of the both development of the thyroid glands and the parathyroid glands. You can appreciate this is a third pouch. The third pouch is a ventral aspect, is a dorsal aspect of the third pouch, giving us the inferior parathyroid and the thymus. Then you can appreciate now the fourth pouch will give us now the ultimobrachial body, which forms the parafollicular cells, and then down in green is now the superior parathyroid, as you can see here. So you just arrange the colors according to how they look on their derivatives here. But remember, all these derivatives are coming from neurocrine cells because the pharyngeal arc is from the neurocrine cells. So that's the parenchyma aspect of the thyroid and also parathyroid. But now remember, so we have now the mesenchyme surrounding these glands, giving us a stromal tissue, which will give us the capsule of those tissues. Also remember, angiogenesis will develop now to supply these glands, given their endocrine glands. And also they will be innervated in that aspect. So what about the cell types now of these parafollicular cells? We have oxyphil cells, which have unknown function, and then clear cells, or the chief cells, which secrete parathyroid hormone, which has now regulation of calcium levels via bone, kidney, and gut target organs. It targets the bone, the kidneys, and the gut, the GIT to be specific. Yeah, to regulate calcium levels in the body. What about now some of the anomalies of the parathyroid gland? You can have ectopic parathyroid glands being found at the various locations. You can have intrathyroid glands. Now they are not found on the surface, they are found inside the thyroid gland. You can have supernumerary glands, supernumerary parathyroid glands, such that they are more than 4. Maybe they can be 6, 8, something like that. But they are more than 4. Ectopic, they are not found on the normal location. They may be in the tongue, maybe they are found in the mediastinum, in the abdomen, or something like that. And then you can also have this absence of parathyroid hormones being associated with the George syndrome. So this now you can have supernumerary parathyroid glands. You can appreciate down in yellow those are the normal locations of the parathyroid glands. So you can have 2 superior parathyroid glands and then 2 inferior parathyroid glands. And this aspect you can see these are undescended high cervical parathyroid glands. They can be intrathyroid or inside the thyroid. They can be tracheal on between the trachea and the esophagus. So tracheoesophageal tube, tracheoesophageal parathyroid glands. They can be along the thyroid and the thymic ligaments, and then they can also be formed in the mediastinum or maybe in the carotid tissue. Those are just ectopic regions of this parathyroid glands. So we can now narrow down to the pituitary gland. The pituitary gland is one of the simplest formed glands actually. Maybe you can appreciate the normal anatomy of the pituitary gland. We know it's just connected to the hypothalamus by this infundibulum. Then it has lobes, 2 lobes, anterior lobe, which is adenohypophysis or anterior pituitary lobe, and then neurohypophysis, which is now the posterior pituitary lobe. Of course, we'll expect now the posterior to be neurohypophysis. So neuro means it has a nervous tissue connected to the hypothalamus. Then our adenohypophysis, this one doesn't have like connection to the hypothalamus directly. But now you can appreciate that the adenohypophysis has pars tuberalis and has pars distalis. In addition to that, we have now pars intermediaris that is found there, interglandular cleft. Then the infundibulum at this point has a median eminence, which is now the infundibular process. The median eminence, and then you can find the infundibular process there, and then pars nervosa now, the neurolobe. Of course, we can talk about the various nuclei that are connected to this neurohypophysis, paraventricular and supraoptic nucleus, which secretes oxytocin hormone and ADH hormone respectively. So maybe now we can check on now the embryological development of this pituitary gland of the hypophysis. So tissues of origin, it comes from ectoderm, specifically the outpocketings of the spermodium. So the roof of the stomodium will give us the Radke's pouch. So ectoderm, the Radke's pouch, the surface ectoderm at this point, and the outpocketing of the stomodium will give us the Radke's pouch. Note the surface ectoderm. Surface ectoderm. Then the diencephalon at this point, which is one of the 5 brain vesicles, it will develop an extension downwards called the infundibulum. So remember the diencephalon comes from neuroectoderm. So ideally, the whole of pituitary gland comes from ectoderm. But now, the Radke's pouch, which forms the anterior pituitary, comes from surface ectoderm. Then the posterior pituitary, which comes from the encephalon, ideally comes from neuroectoderm. But all of them come from the ectoderm. The difference is one comes from the surface ectoderm, the other from neuroectoderm. So at now, around the 3rd week, this Radke's pouch is actually like outpocketing from the roof of the stomodia. Remember, stomodia is a future mouth. So the flow of the roof of the future mouth now undergoes formation of an outpocketing, which goes upwards to give us the Radke's pouch. But around now the 3rd week, the Radke's pouch evaginates on the oral cavity and grows towards the infundibulum. Remember, the infundibulum is developing downward. Then the Radke's pouch is ascending upwards. So of course tells you they will meet somewhere, will make a contact, then the Radke's pouch will lose contact with the stomodium. So this is what I'm trying to explain. The flow of the forebrain, to be specific, the flow of the infundibulum of the diencephalon is the roof of the stomodium. So you can see the invagination that is happening to give us the Radke's pouch, then the downward extension of the diencephalon to give us the infundibulum. So some will see this, the last 2 processes in the next syllabus. The first and the second process stages, we need to appreciate them in this line. So at around now the 2nd month, the Radke's pouch will lose connection with the oral cavity. Around the 2nd month, the Radke's pouch will lose connection with the oral cavity or the stomodium and comes into contact with the infundibulum, which is extending downwards in the 2nd month. So contact. So further proliferation of the Radke's pouch gives us the adenohypophysis or the anterior pituitary gland. Then some part of it grow along this developing infundibulum to form the pars tuberalis. Remember the 2 parts of adenohypophysis was pars tuberalis and pars distalis. So pars distalis now will come from now the proliferation of the Radke's pouch. Then infundibulum forms the stalk and pars nervosa or the neurohypophysis, or now the posterior pituitary gland part of the pituitary gland. So infundibulum, given the fact it's coming from the nervous tissue to form the neurohypophysis. Then, of course, now the adenohypophysis coming from the Radke's pouch will form the anterior pituitary gland. I hope that's clear. So a better image showing us the summary between the two. We'll have now, this is a diencephalon. You can see this is a diencephalon. You can see they are developing extension downward of the infundibulum. Then is a roof of the stomodium ascending down upwards. You can see this is the Radke's pouch. We come into contact. The Radke's pouch loses connection with the roof of the stomodium, and then we come into contact. So actually, now between the posterior pituitary and anterior pituitary, of course, you have the interglandular cleft, which remains as a space. So the interglandular cleft is from that way. And actually, you can be able to see it here, the interglandular cleft. Then this part is known as pars intermedia also. Pars intermedia is part of the adenohypophysis. So this is actually now another summary of this. So maybe at our own time, we can go through the summary again. What are some of the anomalies of the pituitary gland? We can have an ectopic posterior pituitary gland. So which one that means it did come into contact with the Radke's pouch. Then pharyngeal hypophysis. So that means it's found on the roof of the pharynx. It didn't It's not found in the skull ideally at this point, but it's found in the pharynx, on the room of the pharynx. Then you can also have agenesis, complete absence of the pituitary gland, and then hypogenesis on the level of pituitary gland. You can also have duplication of the pituitary glands. So you have more than one pituitary gland. Then you can have craniopharyngiomas in the cella tussica. So these craniopharyngiomas are just tumors of the pituitary gland. So maybe you can check on the various anomalies of it, but mentioning about ectopic posterior pituitary gland, pharyngeal hypophysis, agenesis or stroke hypogenesis of the pituitary gland, duplication of the pituitary gland, and craniopharyngiomas, tumors of the pituitary gland. They mark the last bit of it, but those are the anomalies of the pituitary gland. There are others, which we can go ahead and investigate. So with that, I just wish you all the best in your endeavors. A point to note is that kindly like, share, and subscribe. And see you soon in our next video, which will be shooting on the development of the teeth. So kindly stay tuned, like, share, and subscribe. I'm looking forward to see you in our next video. All the best in your area.